Greetings, math fans. All right, so this is day 4 of the Harper review. And again, we've learned all this stuff already. So this is just kind of a review. And today's topic actually is square roots, cube roots, fourth roots, right? It's radicals, basically. And also imaginary numbers. Okay? So again, we learned this towards the beginning of this semester. And this is just a little review for you guys. All right? All right, so here we go. So basically, this right here, this is day 4 of our review. If you guys remember, if I give you like the square root of 20, a lot of different ways to do this problem, but the way I kind of showed you guys is, remember I had you write on the top of your paper, 2, 3, 5, and 7. Okay, so what you do is you're dividing it at 20, and you just keep dividing it by 2 until you can't, and then you try 3, and then you stop after 3, and then you do 5, and you stop after 5. So you break it down as much as possible, and you're looking for perfect pairs. Okay, so if I did square root of 20, that's basically 10 times 2, and then 10 breaks down to 5 times 2 times 2. So basically I have a pair of 2's which comes out, and you have a 5 left over, and that's my answer. That's square root of 20 simplified. Okay, so really that's not bad, right? Okay, so 2 root 5. So a couple more things, like if I square root of 5 times the square root of 5, now a lot of you guys might want to go, oh, square root of 5 times square root of 5 is square root of 25, and what's the square root of 25? And you're like, oh, well, the answer is 5. Yeah, okay, that's an okay way to do it, but an easier way to do it is if you get the same number under the square root and you're multiplying it, the square root just goes away. I mean, think about it. Square root of 5 times square root of 5 was just 5. So if I said square root of 87 times the square root of 87, it's just 87. Don't multiply 87 times 87 and then go, oh, I got to break it up. But you're doing all that extra work. If you get the same number, then it just becomes that, square root of 87 times square root of 87, it just becomes 87. Okay? So just kind of keep that in mind. And then we have, so that's multiplying. Then we have adding. So if I say like 2 square root of 5 plus 6 square root of 5, please don't tell me it's 8 square root of 10. It's like if I said I have 2 square root of 5s in my hand, I'm handing you 6 more square root of 5s. How many square root of 5s do you have? Oh, I've got 8 square root of 5s, and that's your answer. Okay? So what about if I give you something like this? 2 square root of 8 plus 3 square root of 2. Now, most of you should recognize you can't add these together the way they are because that one's a square root of 8, that one's square root of 2. You can't combine those together. It's kind of like saying 2x plus 2y. You can't add them together. All right? But what you can do is you can try to simplify as much as possible. That's what you want to look for. Okay? Because if you're given a problem like this, there probably is some simplifying that you can do. So in this case here, square root of 8 is, if I break that 8, I get basically 2 times 2 times 2, right? 2 times 2 times 2 times 2 is 4 times 2 is 8. So I can bring a pair of 2's out. A pair of 2's out, and I get 2 times 2, because I already have a 2 sitting here. And I got square root of 2 left over. So I really have 4 square root of 2. Okay? That's what that simplifies to. Oh, cool. Okay. 4 square root of 2 plus 3 square root of 2. Now I can add those together. So remember, guys, if you have 4 square root of 2's and I give you 3 more square root of 2's, how many square root of 2's do you have? Well, I got 7 square root of 2's. And that's your answer. Okay? All right, so let's keep going here. So what if I give you 2x square root of 18 minus 3x square root of 2? So 2x squared root of 18 minus 3x square root of 2. Again, you can't combine them together. So what you're going to do is, let's see if I can simplify this. Okay, well, square root of 18. Well, if I divide by 2, I get 9 times 2. And then 9, remember, I told you right on top of your paper, 2, 3, 5, and 7. Okay, and actually 9 breaks it up to 3 and 3. All right, that's perfect. So I can pull the 3 out. So it's 3 times 2x square root of 2. Minus 3x square root of 2. So this gives me 6x square root of 2 minus 3x square root of 2. So I can combine these together now. Okay, so basically, again, if these are the same, guys, basically what you want to do is just look at this then and say, oh, 6x minus 3x. That's 3x square root of 2. That's your answer. Okay? All right, so let's do a little crazier square roots now. if I gave you guys kind of a crazy one, so 20x to the 5th, y to the 6th, z to the 7th. Okay, so basically the 20 we already know. In fact, we already did that one. I'm not going to do it again. We know we got 2 square root of 5. So 5 is inside, the 2 is pulled out. So guys, if you have x to the 5th, basically what you're doing is, this is kind of in a nutshell. You're saying, since it's the square root, that's actually important. It's the square root. 5 divided by 2 is 2.5. Okay, I have this remainder here. So that means it's 2 with a remainder of 0.5 or 5 or 1/2, right? So you get the x squared on the outside. That's where this 2 comes from. And then there's something left over. So it's just x. Okay, you're not going to get anything more than just an x left over. You're not going to get an x squared or an x cubed. It's just going to be an x, or there's not going to be anything there. So look at the y to the 6. 6 divided by 2 is 3. There's no remainder. It's 3. So it's y cubed. And then z is 7 divided by 2. That gives you 3.5. So again, the 3 is going to be z cubed. That's this 3 here. 3 cubed. So z cubed. And they got this remainder here, so there's a remainder inside there. So that's my final answer, guys, is this right here. Okay. So we can do another one real quickly, just just to kind of help you guys out a little bit. Let me clear this out of here. So I'm going to do the square root of 40x to the 10th, y to the 11th, z to the 12th. Okay, so the 40, let's start dividing by 2. 2 times 20, 20 breaks up to 2 times 10, 10 breaks up to 2 times 5, and that's it. I can split up, that's 40, okay? So I'm going to pull just that out. So 2, and there's 10 left over. So I want you to do 10 divided by 2, because again, it's the square root. 10 divided by 2 is 5. There's no remainder. So it's x to the 5th here on the outside. 11 divided by 2 is 5.5. There's a remainder. Okay, so it's y to the 5th with a leftover. And then the z is 12 divided by 2, which is, it's messy, sorry, is 6, no remainder, so it's z to the 6th. And that's your answer. Okay, that's not bad. So let's do cube roots. So if I do a cube root, the cube root of 40. Again, on the top of your paper, I'm just going to write 2, 3, 5, and 7. So if I simplify 40, which we just did, it's 2 times 2 times 2 times 5. Okay, splitting it up as much as possible. Now you're looking for perfect cubes. So that's a 3. There are 3 of those. So the 2 comes on the outside. I'm going to put cube root here. And our leftover is 5. Okay, that's not bad, right? So you're looking for 3 of a kind instead of pairs. Okay, so let's do one more. How about the 4th root of 162? I don't really know what that is, to be honest with you, okay? But what I'm going to start doing is I'm going to start dividing it by 2. What happens if I start dividing by 2? This is what I get. I divide that by 2, I get 81. And then I'm going to start splitting up 81. Just to save time, 2 doesn't go into it, but I'm going to start dividing it by 3. And 3 actually goes into it 4 times. So this is what you get when you break up 162. So now I have 4 3s. So 3 comes on the outside. And I have a 2 left over. And that's it. 3 times the 4th root of 2. Okay? And if you want to do variables here, so let's do variables. And it's with the cube root. So if I do cube root, we'll ignore numbers for now. Let's do cube root of x cubed, y to the 4th, z to the 10th. All All right, so you're kind of doing the remainder thing again, what's left over. So 3 divided by 3, that's a really messy 3. 3 divided by 3 is 1. No remainder, nothing left here. So we have an x that pulls out. Okay, 4 divided by 3 is 1.333, or 1 1/3. If you want to put that into a fraction, that kind of helps out a lot. If you do 1 1/3, that means there's a remainder of 1. So it's y, and we have a remainder of 1. So the y to the first power there. And then the z is 10 divided by 3. And that's equal to 3.333, or 3 1/3. So the 3 comes out, so it's z cubed, and there's a 1 remainder as well. So that's your answer, xyz cubed times the cube root of yz. Okay? So let's actually just do h to the 20th power. So you're going to do 20 divided by 3 is 7.666, or 7 2/3. If you would simplify that with your calculator, 7 2/3, that means you have a remainder of 2. So you're going to have an h. That's kind of running out of room here. Guess I can move it over. That's okay. So it's going to be xyz cubed, and it's 7. So h to the 7th times the cube root of yz, and then h squared. Okay, that's pretty good. So remember that writing the numbers 2, 3, 5, 7, super important. Okay. All right. So let's do some operations here. So I give you 3 plus the square root of x plus 4 minus 5 square root of x. Guys, if there's an addition sign there, that's actually really easy. You literally just, you kind of ignore it, because you just basically, you write 3 plus the square root of x plus 4 minus 5 square root of x. So you combine like terms. Now, be careful, this in front of that square root of x, there's really a 1 here. So it might help to write it in there, because then when I say 3 plus 4 is 7, and 1 square root of x minus 5 square root of x is negative 4 square root of x. And that's actually your answer. Okay, so let's do that exact same problem on the right here. 3 plus square root of x, but also put a minus sign in there. So 4 minus 5 square root of x. So the deal with the minus is you got to distribute it to both terms. It's really important, guys. The most common mistake here is people just say minus 4, and they only do it to the first term, and they don't do it to both. So you got to do it to both. So we get 3 plus the square root of x. Distributing that is minus 4, and then plus 5 square root of x. Okay, so same thing as I did before, combine like terms. So 3 minus 4 is negative 1, and 1 square root of x plus 5 square root of x is 6 square root of x. And that's your answer. Okay, that's not too bad. Okay, last one of these, let's actually write, we want to FOIL it now. So we're going to do multiplication. So 3 plus the square root of x times 4 minus 5 square root of x. So basically, you can tell this is not addition subtraction, because there's no adding and subtracting between them. Okay, it's multiplication. So we're going to use FOIL. And you guys should remember FOIL is first, outer, inner, and last. So 3 times 4 is 12. Outer minus 15 square root of x. Inner is minus 5 square root of x. And last is minus 5. What's square root of x times square root of x? Just x. Okay. We okay with that? So now let's combine like terms. Well, there's nothing to combine with the 12. What's negative 15 root x minus 5 root x is negative 20 root x. And then minus 5x. And that's your answer. I think I lost something here. I made a slight error. Oh yeah, what the heck? What am I doing here? I don't know. Sorry guys. This should be plus 4 square root of x. You probably, I know you guys were like following on going, Mr. Gross, you just made a mistake. Sorry, I didn't combine these right. So it's plus 4 root x. So negative 15 root x plus 4 root x is minus 11. Sorry about that. Minus 11 root x. And that's our final answer. Okay? Okay, that's cool. All right, cool. So that's pretty good with operations. Now let's talk about imaginary numbers here a little bit. I don't know if you guys remember that. So an imaginary number is I. What does I represent? Anybody know that? Oh, if you're saying it, I can't hear you because this is a video. And YouTube videos don't respond. Okay, so I is equal to the square root of negative 1. It's pretty messy. Okay, square root of negative 1. That's what you got to remember. So basically, if I tell you the square root of negative 5, you can't do anything with it. But you got the first thing I do is you got to pull out an I. Sounds really violent, but think of it this way. It's negative 1 times 5. That's what negative 5 is. So I got to deal with that. Before I can do any operation, anything at all, I got to pull out the negative out of it. I can't have a negative in the square root, period. You can't do anything with a negative. Okay? So if I pull that out, I get an I on the outside, and I get square root of 5. And now I can't do anything with that square root of 5, but that's my final answer. I root 5. So if I said the square root of negative 25, again, you can't do anything with it until you pull out an I. So I represents the square root of negative 1. So this is what you get. And now you can say, oh, what's square root of 25? Oh, it's 5. So my answer is 5i. Okay? That's not bad. As far as like operations with I, it's just like an x, guys. If I said 2x plus 3x, what is it? Well, you would say it's 5x. So if I said 2i plus 3i, well, it's equal to 5i. It's really easy. So just like combining like terms. So if I give you guys a problem like this, 2 plus 3i plus negative 5 minus 7i. Okay, this is just like numbers, and it's just like the radicals that we just did a little while ago. If it's a plus sign, that's like pretty sweet. It's 2 plus 3i and then minus 5 and minus 7i. Right? When it's a plus sign, you don't have to do anything. Just write this out. You don't have to distribute it all, anything, right? So now you got to combine like terms here. And what Harper wants, math fans, is they want your real part, which is just your number part, first. So numbers first. And they want your i's second. Okay? Think of it this way. You should never be first. You should always be second and let other people go first. It's just a polite thing to do. I don't know. It's kind of random. Okay. Anyway, 2 minus 5 is negative 3, and 3i minus 7i is negative 4i. And that's it. Negative 3 minus 4i. That was easy. Now, if I did the same problem, except I said 2 plus 3i minus parentheses negative 5 minus 7i. Now, be careful. Make sure you distribute the negative. So it's 2 plus 3i. That's plus 5. And then plus 7i, right? Distributing it and then combining like terms. So 2 plus 5 is 7, and 3i plus 7i is 10i. And that's your answer, 7 plus 10i. Okay, so let's go one more step here, math fans, and let's do the exact same problem, but let's do multiplication. So it's 2 plus 3i times negative 5 minus 7i. Okay. All right, so 2 times negative 5 is negative 10. That's first, right? We're using FOIL. And the reason we're using FOIL, again, there's multiplication between here, right? So it's first is negative 10. Outside is minus 14i. Inside is minus 15i. And last is a negative 21i squared, because I times I is I squared. Now, guys, I told you this is like way back in the day, but basically, whenever you see I squared, it's equal to negative 1. You got to remember that. That's like so important. Okay, I squared is negative 1. Got to know that. Okay, so the first thing I do is I see this I squared right here, and see it's how it says minus 21. It becomes plus 21. It's just, you basically just change the sign. Right? Because think of it, negative 21 times negative 1 is positive 21. Okay? Okay, so if I just change that to plus 21, then I can add these together. So negative 10 plus 21 is negative 11. Sorry, it's positive 11. Get rid of that negative there. Okay, it's 11. And negative 14i minus 15i is negative 29i. And that's your answer to that problem. 11 minus 29i. Okay, so notice I have in the order. This is my real part, and this is my imaginary part. Okay, and again, I squared is negative 1. Super important if you ever see that. Okay? All right, we're almost done here. Just do a quick operation here. If I said 3, oops, sorry. If I said 3i quantity squared. Remember, you gotta square everything in there. And there's no FOIL here. If it was 3 plus I, yeah, you'd write FOIL, but this is not FOIL. This is 3 squared, which is 9, and I squared. And what's I squared? Negative 1. So the whole thing is negative 9. Okay? Now that's different than this. If I said 3i squared, that 3 is not being squared. There's no parentheses around it. So it's 3 times negative 1, or negative 3 is your final answer. So different than, if you have it in parentheses versus not in parentheses. Okay? All right, so let's do a couple more problems here with the i's here. All right, so if I said 2 plus 3i quantity squared. All right, now this is where you have to FOIL, okay? Because you got a plus sign in between. So please don't forget, don't just square both terms. That's like brutal mistake. So 2 plus 3i and 2 plus 3i. Okay, and then we want to FOIL. So I do that. 2 times 2 is 4, plus 6i, plus 6i, plus 9i squared. Oh, that's cool. Right there, man. Minus 9. So 4 minus 9 is negative 5. And 6i plus 6i is 12i. And that's your answer, negative 5. Negative 5 plus 12i. Okay? Okay, let's try this one here. 3 minus 2i and 3 plus 2i. So let's see what happens with that. So FOIL it. So 3 times 3 is 9. 3 times 2i is 6i minus 6i and minus 4i squared. Okay, right there, guys. That becomes plus 4. So 9 plus 4 is 13. And, oh, hey, these cancel. So that's the answer, 13. Okay? All right, a couple more. We're almost done. Promise you. So guys, before you can do any operation with a radical, you have to take out, you can't have a negative inside. That's basically what you have to do. So you have to take out the negative. So if I gave you square root of negative 3 times the square root of negative 3, you can't just do, oh, well, negative 3 times negative 3 is 9, square root of 9 is 3. It's wrong. Okay? First thing you do is you're going to pull an I out of there. Another I out of that one. And now I can put them together. What's I times I squared. What's root 3 times root 3? Again, don't do root 9. Root 3 times root 3 is just 3. Okay? So you really get 3i squared. And what's 3i squared? Well, you guys just say, oh, I squared, negative 1. So the answer is negative 3. Okay? How about this one? Square root of negative square root of negative 20. Okay, again, you can't do anything with that square root of negative 20 until you pull an I out. So we got negative I, because the negative is here already, square root of 20. And now I can simplify 20. We already did that back in the day. It's basically 2 times 2 times 5. So I pull the 2's out, and I get negative 2i root 5. And that's your answer, negative 2i root 5. Okay, well, what happens if just one of them is negative? So square root of negative 2 times square root of 8. Well, that 8 is great, but that negative 2, you can't do it. So I'm going to pull an I out. And guys, when you're multiplying radicals together, you just put them together. So it's I times the square root of 2 times 8, or 16. What's the square root of 16? It's 4. So 4i is my final answer. Now, if you weren't good with that and you're like, oh, 16, you could always break it down. 2 times 2 times 2 times 2, right? And then you're pulling out 2 pair, which gives you 2 times 2 is 4, and then there's nothing left over. That's why it's just 4i. Okay? So that's it, my friends. That is kind of an overview, 25-minute overview of radicals, which is the stuff basically I just covered now is what you need to know for that Harper final. All right? That's it, my fans. Have an outstanding day. Adios. Goodbye.